Hey everyone, my name is Lance and this is Amped About Aimpad. Traditionally my videos have kind of focused on comparing a normal keyboard to an Aimpad keyboard that has analog technology, but for today's episode I'd like to focus on comparing our analog technology to another analog technology, the Xbox 360 controller. So as I've looked online for people's comments and feedback and things like that, one common thing that people say is there's no way that a key switch can duplicate the exact experience that you get with a left analog stick of an Xbox 360 controller. So they're basically saying that when you push this joystick to the left, there's a distance there, and that distance is nowhere near the distance of pushing down the key like this. But I'd like to demonstrate that that's simply not true. So I've set up a rather crude contraption, but I think it effectively demonstrates my point. On the left is the Cherry MX switch, which is mounted horizontally, and then immediately next to it is the left analog stick of the Xbox 360 controller. So if I push in this Xbox 360 controller to the left, you'll see that it engages this switch to its full pressed position, and at the same time the left analog stick is pressed to its full left position. So there is a very direct relationship on the distance between the amount that you can push the left analog stick and the amount that you can push in a Cherry MX switch. So looking at this from a different perspective, essentially all that we're doing is simulating what the Xbox 360 controller would do as you move it. So if I were to move the stick up, it would engage the W key. If I were to move it down, the S key, and left and right, the A and D key. But if I were to move it in a diagonal direction, irregardless of what direction that is, I'm going to engage each of these keys simultaneously, and I can measure each of those, and I can tell which direction I intend to be moving as if I were actually using an Xbox 360 controller. So it effectively duplicates the exact same experience you would have using an Xbox 360 controller. Now the other thing that people say is that the amount of precision that you get is nowhere near what an Xbox 360 controller is. And I'm going to show you that that's not true either. Alright, so here we have a precision tester program. The purpose of this program is to define how precise an analog device is. So you'll notice the first thing I want to show off is here on the screen. The precision that shows up here is basically the amount of precision that's available by this analog stick. So essentially every time a measurement is increased on the Xbox 360 controller, it's increased by 369 values. So when I move it up another step, it increases the value by another 369, 369, 369. Essentially every single time there's a unique measurement that it is capable of accepting until I get to the very highest and the very lowest. So that's the full range of motion, or the full level precision is 177 and 174 for the left analog stick. If I clear this out, there's something else I want to show you. Is even though I have not pushed, I've let go of the joystick here, you can see that right here is where the cursor is resting. So I am not able to precisely leave it exactly in the middle unless I force it kind of right there. So there's this area of the readings that are happening that are extremely imprecise, because when I let go of the joystick, it could be anywhere in that area, and that's a pretty big problem that I'll kind of demonstrate in a second. The other thing that I like to do that shows a kind of a weakness of the controller is precise movements left and right, up and down. So if I move to the left precisely, I can pretty close keep it in there, and the same when I go left. Oh dear. And when I go up, oh my gosh. And when I go down, oh yeah, I got that one nailed perfect. So it's possible. I'm not exactly in the middle, but it is pretty straight. So if I do my best to do a straight left and right, I can do that pretty well. But that is kind of a problem in some games that I've been playing. Recently I was playing a game with my friend, and he was using an Xbox 360 controller, and he wanted to go to an immediate direction to the right, but he was maybe kind of more up in this area. And the game perceived that he didn't want to go immediately to the left, he wanted to kind of go up. And so it made him jump at an awkward angle and fall off on a cliff or something like that, and it was a bad gaming experience. So there is some advantages to be able to going immediately left and right, up and down. That's not possible with an Xbox 360 controller to a certain extent. The other thing I do want to show is that based off of how the Xbox 360 controller is put together, it's impossible to reach each of those corners of the measurements. So it's impossible to reach that point in each of those corners. I cannot move it simply because it's circle based. Is that a big deal? Maybe, but maybe not. If you were to try to combine this in terms of movement, you can't move as fast as you possibly could in those diagonal directions. So the game developer would have to keep that in mind. But that is kind of a shortcoming in my opinion. Okay, so here we have the Aimpad prototype now set up for the Precision Tester program. So the first thing I want to show is the level of precision that we're going to get here. So if I make some small measurements here, you'll notice that my level of precision is now 1700 and 1300 on the X and Y axis. So that means that every single time it takes a measurement and increases the value by 38 across that big long spectrum of 3000 or 65,000 all the way down to 0. So you can see the level of precision that we're getting with the Aimpad prototype is significantly greater than the Xbox 360 controller, and so even very, very subtle movements are actually perceived by the game and by the device. So you can already tell that is pretty significant. That's largely due to the more powerful microcontroller, and the analog to digital converter that we're using is much better than the Xbox 360 controller, but the point still stands that you are able to get the level of precision much greater than the Xbox 360 controller. The other obvious thing here is that if I want to stay within those lines, because I have just single directions controlled by these keys, it's very easy for me to maintain direct control over that axis, left and right, up and down, and I can also reach the corners perfectly, which is impossible on an Xbox 360 controller. Now that doesn't mean that I can't do any other points on the whole XY axis spectrum. I can reach any point in there and be as precise as I want to based off of how I'm moving the controls there, but you'll notice it is a significant difference between the Xbox 360 controller, and it is far more precise than is possible with an Xbox 360 controller. Okay, lastly, I'd like to focus on something called dead zone. So before I get into that, I'd like to kind of show what dead zone is and why it's important for Xbox 360 controllers, but it's not really necessary for Aimpad technology. So to kind of help demonstrate this point, the left analog stick of an Xbox 360 controller, it has the ability to go in all these different directions, right? The problem is that in order for this joystick to rest in the middle, there needs to be some type of tension that's pulling it this way and this way and this way and this way, and they're all fighting each other to try to keep this stick centered. But as you're using the stick over time, as just gaming normally using it, sometimes you're going to be pushing left more often than right, and eventually it's going to start to wear out in one of those different directions. And so what happens is, over time, the mechanisms in here will wear out, and the stick will be in its resting point at somewhere other direction than the exact middle. So in order to combat that, game developers have to build in what's called a dead zone that says, okay, let's make like an invisible circle around this controller, and basically any movement that's in this area that's a small amount with a jiggle amount, just completely ignore it. Like, it just doesn't matter. But as soon as you pass that threshold, then we'll start to read the inputs and pass that to the game so that you can move vehicles and move your character and things like that. So that's basically, you have to have a dead zone, and otherwise, if you didn't, you'd start moving in different directions without you actually even moving anything on the controller at all, because that resting point would be off. So Microsoft actually recommends at least a 30% dead zone. So essentially, you're throwing away 30% of that control out the window, so that you don't have any fine movement over very, very small amounts using a thumbstick when the game says throw away 30% of the measurements that you're taking. Okay, so here I have a program that basically takes an Xbox 360 controller and takes all the measurements from it and kind of just gives you a visual representation of what's going on. So right now, if you'll notice here, I've set the dead zone to be none. That means it's just going to take whatever raw values the controller is sending to the computer and display them on the screen. So if I move this around, you can see that it'll adjust those values here, and the left stick will adjust the values here. So you'll notice that I am not at the middle of 0, 0. You'd want to be exactly right somewhere about there to be right in the middle. So if a game were programmed to take advantage of a 0.02 movement, then you would be moving forward and to the left in those different directions. But you can see if I move this off to the left as far as I can and just kind of ease it off a little bit, it will rest at a measurement of 0.238. That means basically 23% of the full range of motion of the stick is teased off to the left. So if there were no dead zone in the game, I'd be cranking myself to the left in a car or walking constantly to the left. So games have to program in this some type of dead zone that will throw all that away, so that irregardless of how much I wiggle this around, then the movement's not being sent to the computer. The problem is that if I want to make really small, subtle adjustments, like left and right, you can see I'm moving left and right, and nothing was showing until I make it past that certain threshold, which is pretty far. It's in this case, it's probably around 25 to 30% or so of a dead zone, and that there's just the technical aspects of an Xbox 360 controller and the way that the mechanisms are designed. You have to have that, otherwise you have unintended movement. So that's pretty bad. Alright, so here we have our Aimpad prototype, and we're using the exact same program we were using for the Xbox 360 controller to test it. But you'll notice here, the dead zone is shown as none, meaning that even though I'm not pushing any keys on my keyboard, I'm still reporting 0 for all the analog functions of the Xbox 360 controller. So the important thing to note is I'm still able to push in the keys a small amount and still get measurements being sent to the game. But the reason why this is so effective is, in contrast to the Xbox 360 controller, where we have each of these 4 directions being pulled against each other, and you have that the tension in each of those 4 directions. On a cherry switch, there's only tension in one direction. So you push against the spring and you go to the fully pressed position, and you let go of the spring and it's at its fully released position. So there is no tension or having them pull against each other, so that's why we can literally have a 0 dead zone on the key switch. So we get a full measurement of the entire key press that as you're pushing it, rather as if you're using an Xbox 360 controller, you have to throw away a sizable chunk of the initial key press, and that leads to a bad user experience, because if you want to make subtle adjustments, you have to know that once you pass a certain point, then it will start to measure and initiate the movement. So you just have to know that any range in this area of moving the controller is just going to be ignored. Whereas on the prototype, I can have very subtle movements, and those subtle movements are actually translated exactly how I intend them to be, because I know that I'm moving my finger a small amount, and it's immediately being sent to the game that I want to move a small amount in that direction. And it gives you far greater precision and far greater control over the game. Alright, so the last thing I'd like to do is demonstrate a new feature that we needed to develop that would actually counteract the effect of the analog dead zones that game developers add. So we noticed that we ran into a problem when we were playing games, and because we're taking a measurement for the full key press of the Cherry MX switch, and the game developer is programmed in a 30% or 20% type of dead zone, that means 20 to 30% of our key press is just completely ignored. And that's just not acceptable for us. We want the full key press to be recognized. So we added in a new feature into our keyboard that basically, using the page up and the page down keys, it allows you to adjust how much you counteract the dead zone that a game developer has added. So if I show you here on Race to the Sun, right now there should be 0 dead zone, And the problem is, if I push this A key to move left, I'm pushing it in, nothing's happening. Now I start to move, and so it makes a big disconnect because I have an intention to make myself move these directions, but it's not registered until I pass that threshold that the game developer has decided to implement. And that makes for a bad type of experience of what I want it to feel like. So contrast that, if I use the page up key, I'm going to counteract the dead zone. Let's see, it's 4, 5, 6, 7, 8, 9, well, somewhere around there. Let's see what it's like now. So if I push in the A key a small amount, now you can see I actually am moving a good small amount. And I can make the intention of my movements very precise, exactly based off of when I want to move. So there's not going to be any dead amount when I push the key. It immediately responds to my movement, so it allows for a much greater, smoother type of experience. And whatever my fingers are doing is whatever this plane is doing, and that's basically the way it should be. If I make a movement, I want that movement to happen in my games. I don't want there to be a dead zone at all. So we've developed that new technology that allows us to do that, and the overall experience is fantastic. So there you have it. The Aimpad prototype, just as good as the Xbox 360 controller, if not better, because on the Xbox controller you still use the right thumbstick to aim, whereas on PC you should be aiming with the almighty mouse. So there you have it. Hope you enjoyed. If you want to see more, go ahead and subscribe. Love to have you. And until next time.